All right, y'all. So I'm going to give you some help here, hopefully some video help for those of you who might be struggling with any of these questions on Unit 6, Section 1's homework. I'm not going to go through and do all of them. I'm going to do some of these that I selected. Hopefully they help you out, and hopefully you can use some of these examples to help you get through the rest of the problems. The first thing here, though, is we're simplifying this, and we do have to check to see if we add absolute values on these two problems because they're both square roots. What tells us they're square roots is there's no number here, no index, but usually there would be a 2 there. But we don't have to have it there. We're looking for pairs, right? That's how we simplify this, right? So really all we need to do is just work with one piece at a time, right? So I'll start with the 16 right here. To simplify that, we break down the 16. That breaks down into 4 times 4. And right there we have a pair. Right? So the 4 comes out. Check if there's anything left of that 16 to go inside of the square root. There's not. So we don't have to put anything into the square root. Now you could have went further. If you broke the 4 down into 2 times 2 and another 2 times 2, that's fine. You end up with a pair of 2's and another pair of 2's, which multiply to give you that same 4. Either way works, you still get the 4. I'm just going to stop with the 4 though. The second thing is now let's move on to the next piece, right? Let's look at the variables. So let's look at x squared. Now there's a couple different ways of doing this. You could just take that x squared and break it down just like we did the 16 into an x times x, right? Showing us that we have one pair of x's. That pair comes out as just an x, right? There's one pair of x's. Another way you can think of it is how many pairs can you take out of x squared? And that's like a division, right? There's only one pair of x's there, right? You could use that idea here for the y's, right? Y to the 8, you could go through and write y 8 times. It just gets a little tedious, right? You're looking for pairs. You got 1, 2, 3, 4 pairs, right? So we would take out 1, 2, 3, 4 y's, but we wouldn't write it like that. We would just write it as y to the 4th power. To simplify our process there, you could think of it in two different ways. You could break it up like this, or you could look at how many pairs of y's can you take out of 8 total y's, right? How many times does 2 come out of that? And that's 4, which is where that 4 is coming from. So there's 4 groups of y's. Now for both the x's and the y's, there's nothing left over, so nothing is going to end up going back into that square root, meaning we don't need it anymore. So this right here is our final answer. We have 4 x, y to the 4th. Now the last thing is anytime we're doing square roots, you do have to check, do we have to add absolute values? You only check for square roots and you only check on even exponents, right? So you look at the x squared, that's an even exponent. If it comes out in your answer down here as odd, that's when we add absolute values because it started even, ended odd. Versus this y to the 8th, yes, it's an even exponent. We check, it ends up as an even exponent here. Because it ends as an even exponent, we don't have to add the absolute values. We only add the absolute values to the odd exponents because we have to force that variable to be positive. Okay, now we're going to go through number 15. I'll go through it a little bit faster using some of those quicker methods to show you that you don't have to spend as much time as I just did on there. I'm just trying to show you the process. 15, again, we're simplifying. We're doing the square root because there's no number here, so we're looking for pairs again, right? I would start off by breaking down that 81, right? Again, the easiest way to break down an 81 would be a 9 times a 9, automatically giving you that pair of 9's. So that 9 comes out in front, and we still have that square root there. I put that there to just in case there was anything left over, right? Also, before I forget, let's bring this negative 3x. We're just going to bring it down in front, right? We still have that negative 3x. We're going to multiply to. Now, after you deal with the 81, move on, right? Let's deal with the x to the 7th. Again, we're looking for pairs. How many pairs of x's can you take out of 7 total? 3, right? So you would just take out 3 total x's, or x to the 3rd power, saying there's 3 groups or 3 pairs inside of that. Or if you want to write it out, 5, 6, 7. one group, two group, three pairs there. That's why we have x cubed on the outside. There is, however, one x left over, so that leftover x stays inside. It doesn't have a pair. Okay, now work with the y's, right? Y squared, how many pairs can you pull out that? Well, that is a pair, right? That's just a y times y. So that comes out as just a y there. No y's left over, so that's all that goes inside of our square root. Now we can simplify a little bit. Negative 3 times 9 is negative 27. X times x cubed is x to the fourth. And then we have a y with the square root of x left over. Again, we did a square root. We have to check for this adding absolute values. So you look at it. Started odd, we don't have to worry about it. Started even here, right? It was a y squared when it was in. We did the absolute value and ended up with just a y. Because it's just a y, you do have to make sure you add the absolute values. That's an odd exponent, forcing it to be positive. That would be your final answer there. All right, so here we go. Some help here on number 18 and 21. The first thing is start by looking at 18. Are we doing cube roots or are we doing square roots, right? There's no index here. That squared almost looks like it, but it has to be attached to the radical. So since because it's not, we are just doing a square root, so we're looking for pairs. The first thing I want to do is this 3x squared. It's out in front, so let's just keep it out in front. Don't forget about it, right? Hold on, let me move that down a bit. Now what we want to do is deal with this 40. So break the 40 down. That's 4 times 10. 10 becomes 5 times 2. We break it down until we find pairs. There's no pairs. Break down the 4 into the 2 times 2. Okay. And then now let's find the pairs. Now we have one pair of 2's right there. That 2 will come outside of the square root. This stuff that we didn't use, those two numbers, the 5 and the 2 that we didn't use, stay inside of the square root. Now you could just multiply those back together to give us a 10. We'll do that eventually. I just want to show you that 5 and 2 stay. They're not a part of a pair. Now let's move on to the variables. First start with the x. We're looking for pairs. There's just one x. There's no way for us to take a pair out right there. So that x is going to stay inside of the square root. And the last thing we need to look at there is y to the fourth power. How many pairs can you take out if there's 4 total y's? 2, right? There would be 2 pairs of y's, which would come out looking like a y times a y. But we can just write that as y squared, right? There's no y's left over. Again, how we got that? 4 y's, showing us that there's 2 pairs of y's, which would come out as these 2 y's right here. Okay. Now the last thing we have to do before we finish off this problem is simplify, right? So we go 3 times 2 is 6. The x squared, we can't multiply it to anything, so it stays x squared. The y squared, again, nothing to multiply to, stays y squared. Deal with what's inside the square root. Now we can do 5 times 2, give us that 10 back, and then that x right there. The last thing that we have to do is make sure to check whenever it's a square root, do we need to add absolute values? Right, now we didn't do anything with this x right here, so there's nothing that we need to worry about for absolute values. This y to the fourth power, though, it does start even, but when we look at our final result here, it ends as an even power, forcing that y to be positive, so we don't have to worry about putting absolute values there. It's only when it starts even and ends up as an odd exponent at the end. So that would be your final answer. Now for 21, we're moving into a different problem, right? Now instead of square roots looking for pairs, we're looking at the cube root. I guess we're looking for triples, right? Groups of 3. The process, though, is the same. Right? What we're going to start off by doing is break down the 27, right? That's a 9 times 3. The 9 breaks down into a 3 times 3, which is good because now that gives us a triple of 3's. One group of 3's would come outside of the cube root as just a 3. Right, now let's put the cube root Just in case there's anything left over of the 27, there's not, so nothing goes inside of that. But you do want to make sure you check. Now move on to the next, right? X to the 12th power. That's saying how many triples, how many groups of 3 can you pull out of 12 X's? You could go through and write 12 X's and circle those, but at this point, I would highly recommend just thinking of how many groups of 3 can you pull out of 12. The easiest way to think about that is 12 divided by 3, right? Because we're looking for groups of 3. Gives us 4, saying that there would be 4 groups of 3 X's, right? So that would look like X times X times X times X, 4 groups. But we could just say X to the 4th power. That's how you say 4 groups of X, right? X to the 4th power. There are no X's left, so we don't have to put anything inside the square root again. To finish it off, end with the Y to the 15th. Again, I wouldn't recommend writing Y's and circling that. It's just like there's 15 total Y's. We're looking for groups of 3, so divided by 3 is telling us that we can get 5 total groups of 3 Y's out of that. Okay. Again, you could write 5 Y's like this on the outside, but really what we end up doing is just writing a Y to the 5th power, saying that there were 5 groups of a triple Y, right? Now, because of that, there's no variable or number left inside of the square root, or the cube root. So our final answer is just that. Now I'll rewrite it so it looks a little bit better. 3x to the 4th power, y to the 5th. That finishes off that for cube root. All right, so here's the last couple of examples that I'm going to do here for y'all. I'm going to try to give you some chance to like try some of these out on your own as well. But what we're going to do here again is now on both of these we're doing cube roots, so we're looking for triples, right? Looking for groups of 3. The first thing I would recommend is that 2x right there. Just make sure it's out in front. Don't forget about it, right? That is a part of our like final solution. The second thing that I notice is this negative right here, and we can do cube roots of negative numbers. How we deal with that is if it's a negative cube root, all you have to do is take that negative sign outside of the cube root. It's just going to make our final answer negative. Now I'm going to choose to put it right here next to the multiplying sign, but if you want, you can put it right directly on the 2x. Either way, we take the negative out. Okay, so we've dealt with that. Let's move on and deal with the 24, right? So we need to break the 24 down, see are there any triples. How I think of 24 is 8 times 3, no triples. Can we break it down further? Yeah. 4 times 2 is 8, still no triples. Can we go further? 2 times 2, and now look at that. We have a group of 3 2's, so there's 1 triple there, which would come out of the cube root as just a 2, right? That 3 that's left over that we didn't use, not a part of any triples, stays inside of the cube root. So that 3 will be left inside. Okay, now let's move on to the x's. We have x cubed. You're trying to figure out how many groups of 3 can you pull out of x cubed. Well, x cubed is a group of 3. That's 1 triple right there. So that comes out as an x. Okay. And the last one is the y's. Y to the 5th power. You're trying to figure out how many groups of 3 can you pull out of y to the 5th. Well, the easiest way for me to think of that is there's definitely 1 group of 3 y's in there. How many would be left over? 2 y's would be left over. If you can't do that in your head, then draw the y's out, right? There's 5 y's. Pull out a group of 3 y's, that's where this y comes from right here. Those 2 left over are what stay inside of this cube root. That's everything dealt with inside the cube root. We've simplified it as far as we could there. Now we just need to multiply. All right, so I'm going to go 2 times negative 2 is negative 4. X times x is x squared. And then this y is being multiplied to nothing. What was left inside of the cube was 3 and y squared because they weren't part of any triples. That would be your final answer. Just make sure that you remember to put that 3 right there to indicate that it is a cube root rather than a square root. Okay, now moving on, let's work on this last problem here that I'm going to work on, number 29. Again, we're dealing with a cube root. It has a bunch of information in there, but really once you just take your time, break it down, I think we'll be okay. The first thing I noticed, it's a negative cube root, so let's just take that negative out automatically. So this is what I see now, right? When we take the negative out, now we're just dealing with 4, a to the 6, b to the 11th, b to the 7th, c to the 7th, sorry. So that negative sign is just going to be attached to our answer at the end. Okay, so let's work with the 54, right? Break down the 54, we're looking for triples. 9 times 6 is 54, no triples. 3 times 3 is 9, still no triples, but if we break the 6 down into a 3 times 2, that gives us one group of 3 threes. So that 3 will come out of the cube root. If there's something left over, like that 2 right there, it stays inside of the cube root. I'm trying to give myself some room here. And right now, let's not forget about that negative sign. I'm just going to drag it down. And instead of that being a positive 3, it's a negative 3. We've dealt with the negative now. Now you just need to move on to the next pieces, right? So let's look at a to the 6. We're talking groups of 3 here. How many groups of 3 can you pull out of a to the 6th power if there's 6 a's? Well, that's 2 groups, right? So that would be a squared, right? Or you can go a until you get 6 of them, showing that there's 1, 2 groups. It would come out of this cube root as a times a, which is where we're getting that a squared right there. Okay, now using a similar logic, we're going to deal with the b to the 11th next. B to the 11th, you just need to figure out how many times this 3 go into 11. Now, how I see it is we can go into 11 3 times there, right? 3 times 3 is 9. 3 times 4 is 12. So we can definitely take 3 groups of 3 out of B to the 11th. The question is how many are left over. Again, if you need to write B 11 times to see this, then do it. It's not going to hurt. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, look at that. So there's 1, 2, 3. How many are left over? Well, there's 2 left over. So those 2 left over would stay inside of the cube root. The last one is c to the 7th. You ask yourself how many pairs, or sorry, how many groups of 3 can you take out of that? That would be 2, right? So c squared would be on the outside. How many c's would be left over? 1 c, because 2 groups of 3 c's would be 6, leaving us with 1 c left over. Again, if you need to write 4, 5, 6, 7, write those c's and circle groups of 3 to see how many would be taken out and how many left over, then you should do that. After you do all of that, whether you write it out or try to do it mentally with division, you should be left with this. I'm going to rewrite it all in black so it looks a little more uniform. We got negative 3, a squared, because you could take 2 groups of 3 a's out, b cubed, because you could take 3 groups of 3 b's out, c squared, because you could take 2 groups of 3 c's out of that cubic, out of that cube root. And then what was left after we took out our groups of 3 was a 2, b squared, and a c. We couldn't take out any more b's because you need at least 3 b's to take out a group, and same idea for the c's. That finishes up those examples. Hopefully, whether you write out all the variables as I did on these examples, or if you just do it in your head, you have some way of organizing yourself, because as you can see, it does get a little bit unorganized unless you space yourself out there. So just take your time. If you have questions, send me an email, come by. I'd love to help you out.